Rate Law. Okay, so why do I not have anything on the screen here? I don't get it. It is wrong. Let's see. Okay, Tyler, I'm going to need your help. Why is this not coming through for us?
Oh, it is.
There it is. Okay, good. Hey, can you guys see that at home? Kara and Mason?
No, it went away when you put it to this.
See the notes?
You can't see them.
Kara and Mason, can you guys see the notes there?
You can't see them.
You cannot see them?
No.
Okay, let me try this again. Mr. Wood's an idiot. How'd I click the right buttons there, Tyler? Unless the ones you taught me. Can you see them now?
Yes.
Okay, we can see them here. Great. Okay. Okay, so this is the slide we left off on. Okay, so just real quick, what we talked about before, and today'd be a really good day to have your calculators out. And I am going to do jokes here. Gosh, we got to do jokes. But what we talked about yesterday. So again, real quick, I'm going to make the chapter 12 quiz, which for you guys in class is right here. And if you guys at home didn't get it, you probably should get it tomorrow. I'll also have out the reviews for chapter 12. Moving along here, I'm really hoping by the end of this week we'll be done with everything in chapter 12 and we can maybe start to move into chapter 13. But I'm going to make the quiz for chapter 12 and the lab, the sulfur lab and penny lab for you in class, cohort B will be due a week from Thursday. And for those of you at home, cohort A will be due Wednesday. Not tomorrow, but a week from tomorrow. I think that's March 3rd. And then also test corrections, remember, need to be done by cohort B by Tuesday of next week. By cohort A, they need to be done by Monday of next week, and paper towels as well. So anyways, that is the schedule for what is going on. Okay, so yesterday, and what we're going to do today is a lot like what we did yesterday. We're going to do about 15 minutes of notes or so, 15, 20 minutes of notes. And then here in class, we're going to do this sulfur lab, where at home you guys can work on the lab write-up. But anyways, this I went over yesterday. We talked about the differential rate law, which is what we had been working on, which is where we looked at cut rate versus concentration data. We did the ratios. We figured out the order of the reactions from there. We can figure out the rate constant. Now we're going into the integrated rate law, which kind of introduced a little bit. The integrated rate law, we're going to do concentration versus time data. Okay, so just repeating myself from yesterday. So then what is key is this equation down here. And for those of you that didn't hear me yesterday or were sleeping yesterday, if you go back to your formula sheet, here where it says kinetics, this is the equation I've got here on the bottom of the board using calculus, is exactly the same thing. And so we're going to use that today. And this is why you want to have your calculator out. So just writing this out again, and I would label this. And again, I mentioned this yesterday, but if you didn't get it yesterday, I would write this in today. I would write this in on your formula sheet. Okay, so I would write in right over here where it says kinetics for everybody in class and at home. And I talked about this yesterday. This is, you might want to just call this is for the first of all, I don't think I made enough point of this. This is for a first order reaction. And so you might want to note that this is the first order integrated rate law. So again, if you want to impress somebody today, you could say, man, in AP chemistry, we were working on the first order integrated rate law. And everybody will say, what in the heck are you talking about? But I would write that in, right down here, the first order integrated rate law. The A sub T is the ending concentration. Okay, I would label that. I would write that in, okay? K is the rate constant. T is time. And A0 is your initial concentration. Okay, so the way it is written on the formula sheet, which again, you guys will use, I think the date of the AP test, I think is May 7th. I think that's a Friday. So we're about 2 weeks or 2 months and 2 weeks from that. So we're going to cover as much ground as we can. And of course, on the AP test, you're not going to have this. This might be a really good study guide. On the test, we'll have, again, either right before spring break or right after spring break. I'll let you use the formula sheet. Okay, so we're going to use that today. So we talked about that slide yesterday. And then I talked about this slide too. And the only thing I said that was important was what is written in the sentence there, where what we're going to do now with concentration versus time data, you can see the concentration versus time data, we're going to do a bunch of graphs. We're going to do a bunch of graphs, and if we're going to look for the linear relationship, and when it's, just like it says here, when it's a graph of the natural log of the concentration of the reactant versus time, if that is the linear relationship, then it's first order. Okay, and what we're going to talk about on Wednesday and Thursday, if what gives a linear relationship is the concentration versus time, and I'll talk about this is in the notes, then it'll be zero order. And if it's the reciprocal of the concentration versus time that gives the linear relationship, then it's second order. So it's a whole different way to solve for the order of the reaction. The thing that is not written in here that you should know is the way you determine the rate constant is based on the slope. The way you determine the rate constant is the slope of the straight line. And of course, you could ask a question, you go, well, that's a negative. The graph on the right, that's going to be a negative slope. Well, what we're going to do is we're going to take the absolute value of that. We're going to take the absolute value. Okay, so all that is repeat. So here we go now into using this equation. So this would be a really good time to have your calculators out. So this is a kind of problem that's on our quiz. Matter of fact, I'm looking here at our quiz. This is a problem just like number 4, A and B, right on the quiz. This is a problem that will be on our test. This is a problem that will be on the AP test, because if they've got it on the formula sheet, it's going to be on those things. Okay, I told you we got to do jokes. Here we go. What do you call a man with no arms or legs? Joke day. Tyler, you don't want me no interested in that. What do you call a man with no arms or legs in a hole? Dug a hole. What do you call a man with no arms or legs in the leaves? Rustling around in those leaves. What do you call a man with no arms or legs on the wall? Art. You guys not liking my jokes. What do you call a man with no arms or legs in the water? Bob. What do you call a man with no arms or legs laying on the front door? Matt. You guys aren't laughing there on the computer. I guess you don't think it's too fun. What do you call a man with no arms or legs in a hot tub? Stu. Okay. Did I tell you this one? What does a vampire take when they are sick with a cold? Coffin syrup. Okay, and the last one, and I've got great jokes tomorrow. So when you guys are Google Meeting, be awake for the jokes. I got only one. It's a really good one. But it's a chemistry joke. What did one atom say to the other atom? Did I tell you this one? What did one atom say to the other atom? I have my eye on you. My eye on you. Chemistry. Oh, I got to get on my Black Lagoon mask here so I'm safe from everything and keep you safe. I forgot. Okay. I try. Those at home, those in school, I try my best with the jokes. Okay. So here we go. So again, now we're going to use this. So this is where it'd be a really good idea to have your calculator out just to go over these. So The decomposition of N2O5 is first order. Remember, this is a first order reaction. So when they tell us it's first order, we can use this. And they give us the value for K. So if they say the initial concentration, so the A0 is 0.25, what is the concentration? So AT is X here, and the time is 3.2 minutes. Now there's one little thing about the units here. And anybody here in class, what do you see, Tyler?
You need to change minutes a second.
Very good. Tyler's exactly right. If you guys here or at home, they give us 3.2 minutes, but the value for K, the rate constant, again, notice how the units on the rate constant go with a first order reaction, 1/seconds. Well, those are seconds. So the first thing I've got to do before I go to plugging everything in is I've got to get the units to be right. So I have 3.2 minutes is how many seconds? And then I'm going to plug the numbers in here. So I got 3.2 times 60 gives me 192 seconds. Okay, so now I'm going to use this integrated rate law for a first order reaction. So I've got ln of x, that's x, equals, and I just use the calculator truly.
Mr. Wood, can you tilt down the computer?
Yes. Juliana, is that good now?
That's good, thank you.
Great, thanks for saying that. I appreciate it when you guys do that. Okay, the value for K is given to us. It's 5.1 times 10 to the negative 4, 1/seconds. That is given in the problem. Then I'm going to plug in the 192 seconds. And this is why Tyler was exactly right. So now the unit seconds are going to cancel out. And then ln A0 is 0.25. Okay, so if you guys follow along with me on your calculators, and you guys could teach this better than me, but I'm going to go 5.1 second exponent negative 4 times 192 gives me 0.09792. And this is one of those, I'm just going to be aware that in the end, I want 2 sig figs. So I'm just going to kind of carry sig figs, and then at the end, I'm going to round to 2 sig figs. Okay, and then over here, I'm just going to punch the ln button, the natural log button, and then 0.25. Okay, and that gives me, so I have plus a negative 1.386. Okay, so again, I watch the sign here. So I've got negative 0.09792 plus a negative 1.386 gives me negative 1.48392. Okay, so now what I'm going to do on my calculator, it says the natural log of x. So what I'm going to do on my calculator is I call it the inverse button. It's just the opposite button. So I'm going to go, it's the second button. So I'm going to do second ln and then this number. So I'll do that again. So I'm going to do second ln, inverse, or just switching it, negative 1.48392, and that gives me x comes out. Now I'm going to round to the right sig figs, 0.23. Okay, so again, make sure that you are doing that on your calculator correctly, because again, this is the kind of problem on the quiz, on the test, on the AP test for sure.
So which one did you press?
So what I did, Tyler, and I'm glad you asked that. So what I did, so I got here. So what I did is I hit the upper left-hand button, the second button, which to me means inverse. So I go second, and then I did ln, and then I did the number.
Okay, so my calculator is different. What's it say that like inverse one is for the ln? Okay.
Okay, is that helpful to you? Okay, so Tyler, good question. Did you get it? Not. It's Ethan Ethan knows more about it than me. Okay, questions there? We okay with that? Okay, now on to another one. Here's question B. Again, same concept, same principle, but a little different question. Okay, so how long will it take to change the N2O5 from 0.25 to 0.15? Okay, so again, I'm going to erase this. If anybody needs this, I'll give you one more minute. Okay, so now for B, time is X. Time is what we're trying to find. So for B, so I've got ln 0.15. That's my ending time. Minus K, which is still the same value. So it's 5.1 times 10 to the negative fourth, 1 over seconds. Time is X plus ln in A0 is 0.25. Okay, do the math. Do the math and see if you can solve for X here. So use your calculator. Kyle, do you need my calculator? Again, I watch the sign just as I do this. Okay, so now I'm going to solve for X. So what I get here, time is 1,002 seconds. My unit would be seconds. Okay. Now again, I come back to sig figs. It really, here again, all the numbers here have 2 sig figs. So to sig figs, what I would do is just 1.0 times 10 to the third seconds to get sig figs right. Okay, we'll do one more and then we'll be done for notes for today. Questions there, here or at home? Okay, last one. And again, this is the kind of thing that all these are definitely possibilities for our test, for our quiz, for the AP test. Okay, C says, how long will it take to convert 62% of N2O5 to products? Okay, so again, I'll give you one more minute if you want to copy this now, letter B. Okay, when it's a problem like this, it's just a little bit tricky. What I do is I use, so again, what we're trying to find is what we're trying to find is time. And if it says 62% of N2O5 is converted, how long will it take to convert 62% of N2O5 to products? Which means then that my ending concentration, if 62% has been converted, that means 0.38 is left. So 62%, so if I take 1 minus 0.62, I get 0.38. And I could have done this 2 ways. So I've got this, then minus K, 5.1 times 10 to the negative fourth, 1 over seconds, T, and then ln is 1. So my initial, if it's a percent, and you can do this one of 2 ways. I did this is where I made my initial amount then 1, and I did this as a decimal. You could have made the ln, my initial amount, 100, and this just been 38. Either way, you're going to get the same answer. Okay, solve then for time. So what I get there is the time is 1,897 seconds. Did anybody else get that? We got that? And again, then if I go back to sig figs, again, I should have 2. So we would say 1,900 seconds. And again, like I said at the beginning of the problem, if you have a problem like this, if it makes more sense, just make the ln where it's a percent. You can make your initial amount ln 100, and then here just don't put it in decimal form. Okay, so for those of you at home, I'm going to stop there, and you guys can look at those labs, the quiz, and tomorrow and Thursday we are just going to really be plowing through the rest of chapter 12. So at home, if you guys have questions, you can hang on. I need to get these guys going on the lab, so you can hang on. And if you want to, you guys are dismissed as well. So at home, I'll see you. And if you want to wait again a few minutes, I'll be more than happy to answer your question. I just need to get these guys going.
Thank you, Mr. Wood.
See you guys.